Balancing the levels of the neurotransmitter glutamate and its counterpart GABA are crucial for modulating the overall brain function. When most people hear the word glutamate, they think of the flavor enhancer MSG or monosodium glutamate. And while glutamate is found in MSG, it's also naturally found throughout the body, where it performs many vital functions. Its most important role by far is as a neurotransmitter, a chemical messenger in the brain. Glutamate is one of the most recently discovered neurotransmitters, and there's still much that we don't know about it. One of the most intriguing discoveries is that glutamate acts as both an essential neurotransmitter and a dangerous neurotoxin. Glutamate is the most common amino acid in the body. It's estimated each of us contains about 4 pounds of it. You can readily get all you need from food, since it's common in most plant and animal sources of protein. Additionally, it's a non-essential amino acid, and this means your body can synthesize it when it's necessary. Glutamate is the most abundant neurotransmitter in the brain and the central nervous system. Of all the neurotransmitters, glutamate is considered the most critical for healthy brain function. Glutamate enhances neuroplasticity, the brain's capacity to change and grow, to help you learn, remember, and perform cognitive tasks. Glutamate is critical for human brain development, and this is why there's a high concentration of it in human breast milk. Ironically, because glutamate performs so many functions, it wasn't immediately recognized as a neurotransmitter. It wasn't considered a neurotransmitter until the early 80s, decades after other major neurotransmitters like dopamine, serotonin, and acetylcholine were discovered. One of the ways of classifying neurotransmitters is whether they're excitatory or inhibitory. Glutamate is your main excitatory neurotransmitter. Excitatory neurotransmitters increase the likelihood that a nerve impulse will fire. Glutamate system dysfunction has been linked to numerous psychological and neurodegenerative disorders. In excess, glutamate becomes a potent excitotoxin, and it overstimulates brain cells, sometimes to the point of death. The term glutamate is often interchangeably used with glutamic acid. They have slightly different chemical structures, but for all intents and purposes, they're the same, since the glutamic acid readily converts to glutamate. You can't really discuss glutamate without mentioning GABA, or gamma-aminobutyric acid, another abundant neurotransmitter. Glutamate and GABA are integrally related in both form and function. They have complex homeostatic relationships that bring balance to the level of brain activity. While glutamate is the main excitatory neurotransmitter, GABA is the main inhibitory neurotransmitter. Inhibitory neurotransmitters decrease the likelihood that a nerve impulse will fire. GABA normally inhibits brain activity, enabling you to relax. When you're low in GABA, your brain gets stuck in the on position, and you find yourself anxious, overstimulated, and overwhelmed. Much like the accelerator and brakes on your car working together to control speed, GABA puts the brakes on the brain activity to counter glutamate's accelerative effects. There's an additional connection between the two neurotransmitters. Glutamate is the precursor of GABA. An enzyme called glutamic acid decarboxylase triggers the production of GABA from glutamate. Conversely, GABA can turn back into glutamate as needed. Glutamate is essential for healthy brain function, but the dose makes the poison. In excess, glutamate becomes a potent excitotoxin, and it overstimulates brain cells, sometimes to the point of death. There's two main causes of excess glutamate and its resulting excitotoxicity. Too much glutamate has accumulated in the brain, and the glutamate receptors have become overly sensitive and, consequently, are easily overstimulated. Receptor oversensitivity sometimes occurs in patients with neurodegenerative disorders, even when glutamate levels are not particularly high. Symptoms indicative of a high level of glutamate include anxiety, depression, restlessness, inability to concentrate, headaches, insomnia, fatigue, and increased sensitivity to pain. Glutamate system dysfunction has been linked to numerous psychological disorders and neurodegenerative diseases like Alzheimer's, ALS, autism, anxiety, bipolar, chronic fatigue, depression, epilepsy, Huntington's disease, fibromyalgia, migraines, MS, Parkinson's disease, OCD, PTSD, psychosis, schizophrenia, stroke, restless leg syndrome, seizure disorders, and traumatic brain injury. Brain tissues readily accumulate glutamate, and normally there's safeguards to keep the glutamate from building up to dangerous levels. As authors of one study put it, neurons eat glutamate to stay alive, which usually keeps glutamate from reaching toxic levels. Numerous protein transporter molecules can bind to glutamate and move it out of our brain. Also, the blood-brain barrier keeps the glutamate that's circulating in the bloodstream from entering the brain. And finally, when all works right, excess glutamate should be turned back into GABA. But even with all the checks and balances, there's still times that the glutamate system goes awry. GAD Autoimmunity. Glutamic acid decarboxylase, or GAD, is the enzyme that turns glutamate into its calming counterpart GABA. But it's possible to develop an autoimmune reaction to the GAD enzyme, and this leads to poor GABA conversion. Gluten intolerance, celiac disease, Hashimoto's disease, type 1 diabetes, and other autoimmune diseases are linked to GAD autoimmunity. Vitamin B6 or pyridoxine is an essential cofactor in the conversion of glutamate to GABA. A lack of B6 results in diminished GABA synthesis and the buildup of glutamate. It's also possible to have a genetic tendency for glutamate oversensitivity and imbalances between glutamate and GABA. Traumatic stress can elevate glutamate to abnormally high levels. Many mood-altering substances disrupt the glutamate-GABA balance. Caffeine is the most widely used stimulant. It increases glutamate activity at the expense of GABA. A brain injury or a stroke causes glutamate to flood the injured area. This can be counterproductive, causing brain damage by overexciting damaged neurons to death. There's numerous food that contains glutamate, both naturally and artificially. Glutamate is responsible for giving foods their umami taste. Umami is a meaty or brothy taste that's a little harder to recognize than sweet, sour, salty, or bitter. The average person eats about 20 grams of glutamate every day. For most people, these foods don't cause a problem. Foods that naturally contain glutamate include asparagus, beets, bone broth, broccoli, carrots, cheese, corn, eggs, green tea, meat, mushrooms, onions, peas, sea vegetables, seafood, soybean, especially fermented soy products, tomatoes, and spinach. There's two ways glutamate naturally occurs in food. The glutamate can either be bound to other amino acids or free. The bound glutamate is absorbed slowly, whereas the free glutamate is absorbed rapidly, leading to spikes in the bloodstream. The bound glutamate has no flavour. It's only when it's broken down into the free form that you can taste it. When food that contains glutamate is cured or fermented, free glutamate is released. This is why we find foods like cured ham, aged cheese, and fermented miso so delicious. MSG, or monosodium glutamate, is a highly controversial food additive, and it's used as a flavour enhancer. It's pure free glutamate. It's found mainly in salty foods like canned soups, condiments, snacks, ramen noodles, and refined soy products like veggie burgers. The international scientific consensus is that MSG is safe. However, lab animals who are fed MSG exhibit brain lesions, obesity, stunted skeletal development, sterility, diabetes, liver damage, and death of neurons. One human trial found MSG caused headaches, muscle tightness, numbness, tingling, general weakness, and flushing in some study participants. Some researchers posit the MSG can cross the blood-brain barrier, leading to raised glutamate levels, but we don't know for sure. It's notoriously difficult to study neurotransmitter levels in the brain. When levels in the blood, saliva, or urine can be measured, these results have little to no correlation with levels in the brain. It's not hard to find a list of the reported MSG side effects, even on authoritative websites like the Mayo Clinic. The reported side effects include asthma, back pain, chest pain, burning or tingling, convulsions, diarrhea, flushing, fuzzy thinking, headaches, heart palpitations, migraines, mood swings, muscle weakness, nausea, numbness, psychiatric disorders, shortness of breath, sweating, and swelling of the throat. MSG is thought to be responsible for a cluster of symptoms known as MSG symptom complex. The US National Library of Medicine lists symptoms that range from mild to serious. The symptoms that could be life-threatening and demand immediate medical attention include chest pain, heart palpitations, shortness of breath, and swelling of the throat. However, the medical establishment still denies the existence of MSG symptom complex, and the official stance is that MSG is perfectly safe. Some researchers contend that glutamate brain levels are not affected by MSG unless there's a disruption of the blood-brain barrier. But having a compromised blood-brain barrier is a problem for many people. Additionally, people who have an autoimmune reaction to the glutamic acid decarboxylase enzyme often have strong reactions to MSG and other high glutamate foods. It seems generous doses of MSG don't affect the glutamate levels under normal circumstances, but if you've a compromised blood-brain barrier, the MSG allergy or sensitivity or autoimmune reaction to the GAD enzyme, you might be among the people who react badly to MSG. If you suspect you have any of these conditions, it's prudent to avoid MSG and minimize high glutamate food consumption. When it comes to neurotransmitters, you want to have the proper balance, not too much and not too little. If you experience problems with mood, sleep, focus and energy, you might be producing too much glutamate. If you're easily stressed out, overwhelmed and overstimulated, it's likely you're producing too little GABA. Here's some things that you can do to optimize the glutamate levels and restore the glutamate-GABA balance. Taurine acts amazingly like GABA in the brain. It has a similar structure and it binds to GABA receptors. Taurine excels at protecting the brain from toxic levels of glutamate. The top food sources of taurine are seafood, especially shellfish, poultry, especially dark meat, and nori, the seaweed used to wrap sushi. If you don't eat a lot of these foods, you can take taurine as a supplement. You can eat more ginger or take it as a supplement. Ginger protects the brain from MSG-induced excitotoxicity. The prominence of ginger, seafood and nori in some Asian cuisine might offset the effect of the consumption of the high glutamate foods and MSG. Vitamin C is the most popular vitamin supplement, so you probably have some around your house. You can take it after an accidental MSG consumption, and it protects the receptors that control the release of glutamate, thus providing significant protection against MSG toxicity. Coenzyme Q10 exhibits potent anti-glutamate properties. It's also a powerful antioxidant, and it protects vulnerable brain cells from free radical damage. Valerian, or Valeriana officinalis, is a traditional relaxing herbal remedy. We know it works in part by increasing GABA and by interacting with glutamate receptors to provide anxiety relief. L-Theanine is a relaxing compound found in tea. It's structurally similar to both glutamate and GABA. It's been found to enter the brain and to stimulate GABA production and modestly lower glutamate levels. PQQ, or pyroquinolone, is a little-known supplement once thought to be a vitamin. It protects the brain from glutamate-induced neurotoxicity. Vitamin B6, or pyridoxine, is an essential cofactor required to synthesize GABA from glutamate. Inadequate B6 intake not only diminishes the GABA synthesis, it also leads to the buildup of glutamate. Major depressive disorder is often characterized by depleted glutamate and GABA. Physical exercise has been shown to optimize the balance between glutamate and GABA in people with depression. Chronic inflammation can occur anywhere in the body, including the brain, and chronic inflammation increases glutamate, so take steps to reduce it. Another way to offset an excess of glutamate is by restoring its balance with GABA. Besides the above-mentioned supplements, you can increase GABA by using traditional herbs like kava, lemon balm, feverfew, and passion flower. You could also use the supplement picamillin. Psychobiotics are probiotic supplements that provide mental health benefits. You can check out my video on them for more information. The bacteria in probiotics help to produce neurotransmitters and facilitates the communication between the gut and the brain via the vagus nerve. All exercise is good for GABA production, but yoga stands out as a proven GABA booster. Just a single 1-hour session of yoga can increase GABA levels by 27%. To learn more about neurotransmitters, to book a consultation, or learn about herbs, supplements, and natural treatments, check out my website.